everybody. Welcome to a late session after many hours. And what could be the most exhilarating session than a one about metrics? Now, how many people here use metrics at their day-to-day job? How many people here love the metrics at their day-to-day job? Like 3. Like actually, that one person lowered their hands in the middle. Okay, let's begin. A little bit about me. My name is Roy Osherov. I wrote a book called Art of Unit Testing. These days, I'm actually writing the 3rd edition, and I'm going to rewrite it in JavaScript, just because it's going to be more interesting. I wrote a book called Elastic Leadership, which actually part of this talk is going to touch on some aspects of that book, because I'm going to talk about metrics, and metrics influence behavior. And I believe that to truly be able to release software successfully, we have to learn how to work with people, not just with code. And I'm in the process of writing another book, which is called Pipeline Driven, which is all about why we shouldn't call DevOps DevOps. But really, it's about collaboration on a single pipeline in a feature team collaboration way. So some person named it co-ops, which I kind of like, so maybe I'll rename it. Anyway, so a lot of the pieces of this talk are going to be based on kind of Elastic Leadership and the pipeline-driven book that's upcoming. And the reason this talk exists even is because I started, my professional life as a developer. I started in Visual Basic 6, VB6. Any lovers for VB? Nah. But I loved it, okay? So don't judge me. I still love it until today. VB6, and then a bunch of other languages, Ruby, C#, Java, a little bit of C++. I'm not proud of it. And there were consistent themes throughout my development career. These days, I'm mainly doing consulting and training, but also I see these patterns repeating in various companies that I work with. And one of those patterns is, how do companies use metrics or not use metrics? And I think that the obvious kind of truth that maybe a lot of us already feel is that the world of metrics and measurements in the software world is almost kind of the Wild West. Nobody's really not sure why they're measuring something or what's the point of that, or sometimes we're using measurements that are pointless. Sometimes we use them for various political reasons instead of actually helping us. And I really like this sentence that was attributed to multiple people. I just put a picture of Benjamin Disraeli because it's the coolest picture of the bunch that I could find. There are 3 kinds of lies: lies, damn lies, and statistics. And I believe that metrics definitely fall into that 3rd category that we use today in our day-to-day job. So some of the stuff we're going to talk about today, we're going to talk about the reasons. Why are we even using metrics, and what types of ways are there to use them? Because when I started looking into this area, I also kind of felt kind of clueless. I know that there are a bunch of things that I care about, but why do I care about them? And why do some people care about completely different types of metrics? And where is kind of the map of how it's all supposed to work? We're missing the music theory behind the music. If you were at the keynote about constructing music, we're kind of missing that map of what are we even trying to do here. So I'll talk about that, choosing the right metrics that can either stop hurting us or start helping us. I'll specifically jump into an example from continuous delivery and how some of metrics we're trying to do, we can use those metrics to transform the way our organization is behaving. I'll talk about leading and lagging indicators and some antipatterns. Okay. So usually, if I'm going to ask some of the people in the audience here, what are some of the metrics that you use today? Can anyone, because we're kind of in a small room, so it's okay. So can anyone kind of shout out what metrics do you see on your day-to-day life? Sorry? Latency. What else? Oh, what? Sorry? Code coverage. Okay. Who is, by the way, seeing code coverage? Okay. Anyone else? Any other interesting metrics? Sorry? Velocity. Okay, cool. What else? Yeah, you. Mean time between failure. Okay. That's a good one. Yeah.
I said mean time to recovery.
And he said mean time to recovery. We're going to talk about the differences of those two. And you'll see that you're both kind of trying to fight each other. Anything else?
Incidents of production.
Sorry? Incidents in production, okay. And one last one, if you have a juicy one. I know it's impossible to use the word juicy and metric in the same sentence. Yeah?
In a coffee company, we actually have juice dispensers, and of course we measure errors on those.
Wow, okay. Okay, so what's your name?
Doesn't matter.
His name doesn't matter. He gets 2 points because he actually used the word juice, and it actually makes sense. He works at a coffee company, and they actually measure errors in the juice dispensers or something like that. So, you know what? You win. Okay, you can just go down. Okay, so the purpose. Why do we even use metrics in different types of the company? So the first reason to use metrics is for fun. I was looking for fun metrics to use. The most fun metrics I could see is on Stack Overflow. How many people are trying to exit Vim? Okay? Yeah, it's a great metric. So someone took the time, because obviously they were kind of waiting for the pipeline to finish or deployment. So they were taking the time and they start measuring, okay, which countries are asking this question the most? I put the fonts really small so you can't see, okay? So don't worry about it. Which languages or what types of frameworks are being asked for the most on how to close Vim? The top one is jQuery, by the way, just so you know. And all of these people are just kind of trying to, there are all these people around the world currently trying to close Vim. Can you just imagine that? All of these people just trying to, Vim, die already, come on. And I remember when I tried to close Vim for the first time for me, it was like, I have no idea what I'm doing, right? So these metrics are, first of all, fun, okay? So you don't just think of metrics as boring. You can make fun of your employees, and it's a great way to kind of lose them. So here are some actual reasons that I see on a day-to-day. We'll cover them one by one. Why do people use metrics in the software world? Well, the first one that I see is the planning and progress kind of thing, right? We want to measure, we want to get context of where we are, what we're trying to achieve, know when we're done. We want to predict, or we're trying to predict, and of course we're failing. We want to get hindsight on stuff that has happened in the past. So stuff like burn down charts and velocity and all that stuff kind of fits into that. The whip boards and the Kanban boards fit into that. So there's this whole category of reasons for these types of metrics, so these categories of metrics. Then we have metrics that are about feedback, so continuous integration, continuous delivery. So build and deploy speed, test speed, pull request, review speeds. A lot of these things, these are metrics that are tied specifically if we want to understand this type of world. And then my favorite one is politics. We want to measure because we want to show management various numbers. We want to convince management that some things should be true when they think that they're false. For example, we need more budget for something. And of course, my personal favorite, if we want to avoid management, we'll use metrics. Because management asks us for numbers. We're like, okay, we don't have time for this crap, so let's give them a number so that we can get on with our actual job. Hence, coverage, okay? Another one that I personally like to use, we can use metrics for influencing behavior, right? We all know that you get what you measure. And if I'm measuring you on a specific thing, I'm going to change your behavior on that thing. So if I'm trying to go to an organization, we're trying to move towards a different style of programming, a different way of work, using specific metrics to measure different things and different behaviors can help change the way people behave. And we can measure impact of experiments and make decisions. So this is kind of a weird one, but let me explain. If we're trying to be an agile company or an agile team, to me, the real point of being agile is being able to change and constantly experiment with different ways of working. So maybe for the next 3 months, we're going to experiment with working with sprints, and then another couple of months, we're going to experiment with a different way of working without sprints, or another time we could use test automation for something we used to do manually, et cetera, et cetera. So we can have a bunch of different experiments and constantly learn something. And the measurements that we use are the learnings that we get. Because if we're doing experiments but we don't measure anything, how do we know that we actually affected something for better or for worse. And this is stuff where lead time, how long it takes to actually deliver, escape bugs, amount of value delivered per iteration, those things can be affected by those experiments, and we can decide to do other experiments based on those numbers. So my strategy is usually to combine. When I go to organizations, I usually recommend that we use, first of all, we have to understand how people work, and we want to influence them to change their behavior. We want people to do test-driven development. We want people to work on the pipelines and work with Jenkins files. We want people to write tests, automated tests instead of doing them manually. All of these things are things we're going to get a lot of pushback on, right? I'm sure some of you have seen this in real life. People are afraid of these changes. And a lot of times they're afraid because of the way the system is built around those people. There's a great book called How to Change Anything. In that book, there's a great sentence that says, for every behavior that you see, the world around that person is perfectly designed for that behavior to happen. So it's our job to find out what is the design of the world around that person and try to change it. And the metrics are a way for us to change the system around that person so that they're measured differently. Because if I get less money at the end of the year by doing continuous deployment, and I get more money by writing more code, or you know what, if I get more money by finding more bugs, right? And I have 3 kids that I need to feed, you know what I'm going to do, right? I'm going to find a bunch of bugs. They don't have to be good bugs. I can even generate bugs, right? I'm sure that doesn't happen. But what if I get more money by generating coverage? I'm sure nobody here that happens to them, right? Like nobody here ever gets to this point where the team lead comes in and says, okay, for this sprint, we have to raise our coverage by about 20% because the other teams are kind of gaining on us. And then there's people in the corner going, I know how to get 10% in 5 minutes, right? And then they write a test with a bunch of loops with no asserts, and they get coverage. Everyone's happy, right? So you measure, and you get exactly what you measure. So I find it that the influencing behavior is the key point, but the experiments are the thing that drives us towards new types of behavior. Because not only do we want to measure, we also want to change something and measure how that change affected us. So there are all these different kinds of categories. Which ones should we use for which category? Which metrics should we use? I mean, look at all these. I just kind of Googled very quickly just types of metrics. Look at all these beautiful, amazing metrics. If there are any project managers in the room, they're like, oh, some of these look really cool. Like a candy shop. Oh, we should definitely, number of requirements in test. Oh, that's good. I like that one. Okay. This is chaos. This is like, the huge dilemma. Which ones are right for us? So another great book that I recommend is called How to Measure Anything. Have you noticed the pattern in the books that I read? Like how to X anything, whatever. How to change anything, how to measure anything. I think my next book, I'm going to kind of rename it How to Test Anything and just be done with it. Get a lot of money for it. So How to Measure Anything talks about really what is the process of measurement, why are we testing, why are we measuring some things, and even how to measure things that we feel cannot be measured today. And I find that that's a very good, it really kind of set my mind at ease for a lot of things that I was asking for. So the first thing it talks about is what is your dilemma? Why are you even measuring it? You have to have, when you measure something, you're trying to support a decision that you want to make. And if you don't have a decision or a dilemma that you're trying to solve, then your measurements don't actually mean anything. So measurements have to be tied to something that we have to decide whether we do it or not, whether we up something or down something. Whatever it is, we have to have a dilemma pushing for us. So I'm going to choose a bunch of dilemmas from the world of continuous delivery, a world which we're all kind of living through the pain right now in companies trying to transform to that world. So this is one area of dilemmas, and I've chosen the 3 dilemmas on the left. How do we increase quality without hurting it, right? We don't want to hurt quality, we just want to increase it. We want to increase the speed, because we're doing continuous delivery, and we want to get people to learn skills. These are kind of dilemmas. How do we approach these things? They're kind of organizational business goals, and how do we even affect those things? So we have goals on the left, and then the dilemmas are, okay, given that we want to do the things on the left, if we want to increase the speed, we should definitely automate some stuff. Which stuff should we automate? Where are the bottlenecks in our process? What skills are missing for the people to be able to work in continuous delivery? What structure should we use? What type of process to use? Now, the answers to these questions are usually coming from experiments, right? Because we try different things and then we see which ones are right for us. And those experiments have to be supported by metrics. So I'm going to give you two of the most common metrics that I recommend to start with. They're called lead time and cycle time. Is anyone here at their company today measuring lead time or cycle time? Actively measuring it and seeing it at like every iteration at least or something? No? So, okay, very, very few people. And I believe that every software company is trying to change, should have those metrics, and those metrics should be visible to the teams at all levels, not just at the project management level, et cetera. Because maybe if this was a crowd of managers and project level and C-level, we would get more hands raised up. But even companies that are trying to achieve these are not even sure how to measure these things. So I'll give you an example. What happened? How do we even get those two numbers? And I'll explain what they mean. To understand, to get what they mean, we have to look from the point of view of a feature, okay? My kids chose this graphic. I thought it was going to be more interesting because we're talking about metrics, right? So let's take a feature, and if I want to measure lead time, which is how long it takes me to deliver that feature to production, I'm going to put a camera on that feature's head, and that feature is going to take a film of everything that happens to it from the moment it is created until the moment it appears in production and it's running and it's turned on. Okay, so we'll take that feature and then we're going to ask, okay, oh dear feature, tell me everything that you're going through. So the feature might say, okay, I start with a feature request, and then I go through analysis, and then I go through design, and I wait in the backlog for a while, and then people are developing me, and then I wait a bit as well because they're developing other features as well, and then I go to staging, and I go to testing, and finally I get deployed. And this is our lead time. Our lead time is from the moment that feature has hit the kind of the factory floor where it has been created, let's say in Jira or as a Word document. From the moment it's no longer just an idea in someone's head, but it's articulated in one of the systems of the organization to the point where that feature actually ends up in production. So, lead times can be pretty long in organizations. They could take weeks, they could take months, sometimes they can take years, depending on the size and the bureaucracy in the organization. But then lead time, we can also look at cycle time, which are kind of if I'm looking at it only from the view of my development team, only the things that I control, I can say, okay, from the moment it appears in my backlog as a team to the moment where, if I'm in a very bureaucratic organization, the moment that feature hits the staging environment, for example, or the test environment. These are all huge anti-patterns, by the way, right? But we still have to measure what is the cost of these anti-patterns. So no matter whether we're feeling great about the way we're working or we're feeling bad, we have to articulate what it is that we feel and put a number on it. So this is how we can put numbers on it. So a lot of teams, when we start talking about metrics, they can say, well, I have no idea how long it even takes a feature to get to my team, because that's in a different organization, a different set of people, and I have no idea what happens to the feature after it gets to this environment. So at the very least, we start measuring cycle time, and I'll try to get another meeting in the organization level with the people who are outside of the team to try to get their mapping of what goes through the feature all the way through. So I have a bunch of placeholders in this diagram, and it will probably take 2 or 3 meetings to field that diagram, and each meeting is 2 to 3 hours. Yeah, that's the way it works at the beginning, because we have to map the process. And a lot of times, we don't even know what are the columns in each one of these things. So a common cycle time that a lot of teams begin with is the cycle time from where the team has access to the feature to the point where the team is deploying the feature, hopefully to production, but sometimes not even there. The next item on the lead time, cycle time, is also the wait time, because the wait time is actually a pretty significant chunk of work. So wait times, right, you can see them right here. Let's see if this works. Yeah, wait times. So wait times are where the feature is saying, I'm just sitting there and nobody's working on me, right? Someone wrote the feature in Jira, and then it sits in Jira until there's a meeting, and in that meeting, someone's talking about that feature. Between the meeting and the time it was written, 2 weeks might have passed. And then from the moment the feature was approved until it's actually coming into the team's backlog for one of the iterations, maybe 3 months might have passed. This is all waiting time, idle time, time that the feature is not actually being worked on. Why is this important for us? Because when we have a total lead time, right, it takes us, if I have this number, and that number might be 4 months for a feature on average to go from the idea to production, that also tells me how competitive is my company, right? So when we're trying to change things at the organizational level, at the team level, we have to prove to our managers that the changes we want to do are actually helpful to the company. I mean, we all feel that those changes are good, but now we can actually put numbers. Because I can go to my manager and say, look, it takes us about 4 months to deliver a feature on average, but the total wait time in those months is Y, right? It could be, let's say, 3 months, or it could be even 2.5 or 3.5 months. It doesn't matter. But it's usually a big one. And we can start removing those waiting pieces by adding automation or by changing the process or doing a lot of different experiments to change those things. But now, not only do we change things because we want to change them, we change them for a specific reason. And our measurement is supposed to tell us whether we did a good job or not. So our efficiency is basically how much time the feature is actually being worked on out of 100%. And in many organizations, bureaucratic organizations, it could be like 3% out of the entire feature's life. So for every $100 that you spent on creating that feature, only $3 might have actually been put to use working on that feature. So, and the rest is almost wasted. And you can track this in Excel. This is usually what I do. I'll just put Excel, and I'll change the names of the columns when I work with the teams. And I encourage everyone to kind of to have those meetings at the beginning. And even if, and this is something I learned from the book, even if the number you come up with is a completely kind of, we think that's the right thing, you can usually get a lot of numbers from the systems that you work in. I can find out when a feature was created in the system, and I can find out when a feature was marked as done in the system. And a lot of times that's one indication, but I also do the meeting with the other people in my team so that we can see whether what the systems are telling us and what we feel is true is the same or different. A lot of times there's going to be quite a good correlation. Either way, we're going to end up with a number. Could be 3 months, could be 4 weeks, whatever it is. And even if that number is not accurate, it just has to be consistent. What does that mean? If I'm measuring my lead time over every iteration or every month, it doesn't matter that my numbers are exactly correct. It just matters that my understanding of how long it takes to deliver it is consistent. So if I am the person who said that it takes a week to develop a feature or to test a feature 3 days, and now I'm the same person, I'm saying, look, now it takes me a day. It doesn't matter if I'm exactly accurate that it's a day or a day and a half. What matters is that the trend line goes down. What matters is that our understanding is that things are taking shorter amounts of time, so the trend line will go down, and that's what we're looking for. We're not looking for a number as much as we are looking for a number that goes down when we're talking about lead times. So lead time is part of 4 main metrics that people usually talk about in the world of continuous delivery. And collectively, they're also called lagging indicators. I'll explain what that means in a second. But mean time to recovery, lead time, escape bugs, and release frequency are all kind of these very high-level metrics. And if I asked you all, what are the numbers for these things? Usually they're quite easy to come up with. I can tell you how many escape bugs I had in the previous release. These are not numbers that are difficult to come up with. But is it easy to change them? That's our problem. And that's the thing about lagging indicators. Lagging indicators are things that are almost impossible to fake, right? It's almost impossible because to change them, there are many different things. Basically, we're working in a complex system. We've already heard in this conference. And in the complex system, there are still measurements that we can do to see whether the outputs are what we're trying to do. And then we do experiments at the bottom to see whether the outputs are changing. So lead time, remember our objectives? So we can use lead time to see whether we've actually increased the speed. What about the other dilemmas? Well, we can use cycle time and we can use wait time to see whether we are removing the right bottlenecks, whether our automation is actually helping, right? Because now I can go ahead and say, well, we're going to spend a couple of weeks just writing the automated test because we don't have any. But maybe that's okay because our cycle time is much lower. Maybe that's okay because our wait time is much lower. So now I can go ahead and try a lot of experiments on the right, and I should be able to see an effect on the lagging indicators of lead time, and at least on the cycle time and the wait time. What about increasing quality? How do I measure that I increased quality? Well, one of the nicest lagging indicators that I like is escape bugs. Because escape bugs are the bugs that escaped our system, escaped our pipelines, and made it all the way to production. Escape bugs are, it's basically almost impossible to fake them because they either happened or they didn't. It's very easy to measure. But how do we actually affect those, that kind of metric is something that we are not sure how to affect directly. So we can still do a lot of things on the right. For example, we're automating things. Did we actually increase the quality with our automated test? Is our escape bugs number actually lower now? Is there a trend line that goes somewhere? How do we teach? How do we know that we taught skills to people? Well, what if we came up with this metric? % of cross-functional people in our teams. So a cross-functional person is a person that can actually work in multiple different layers or different tech stacks. We can measure how many people we have, and we want to see a trend line that slowly grows. And this would also help us to influence the behavior of the teams if the teams can see that they're being measured by those numbers. Okay? Now, technically, yes, you can fake that because that is not a lagging indicator. It's very easy to say, well, I now know Angular. Okay, sure. But I will truly know if you know Angular if it affects our lead time, if it affects our wait times, because a lot of times waiting is about, well, I'm done, but I have no ability to help the other people in my team because I have no knowledge about solving their type of problems. I work in mobile, they're working in backend, I have no idea what they're doing. But maybe that will be reduced just by the fact that our skills are being kind of improved. And there's another method thinking of it, if you've heard of OKRs, objectives and key results. That's another way of thinking about it. And I heard about this after I looked at the lagging and leading indicators, which we'll talk about. And this is a very common management metrics. If your organization is using OKRs in some way, or you're thinking about it, this is actually good news. Because OKRs are all about business objectives, key results, and key results are lagging indicators, those things that we talked about before. What we're missing now is the lower level actions that will lead to change the lagging indicators. So these are all the things that we didn't actually measure. Right? Code coverage. I didn't talk about code coverage up until now. Does it even matter? Number of automated tests, unplanned work, build time. How many deploys did we have per day? We all agree that these kind of feel like they might make sense in our world. So why didn't I discuss them? And the reason I didn't discuss them up until now is because these are not lagging. They're leading indicators. So let me explain the difference. Leading indicators are the things that we can affect today. Okay, but they don't necessarily mean that we're going to achieve our goals. There are things that we think that if we continue doing them, we will affect the lagging indicators. For example, if I'm trying to lose weight, which I am, don't laugh. So I can start having a bunch of leading indicators. Well, how many calories per day, and how much do I burn? What's the in and what's the out, right? And I can measure different things, and I can weigh different things, whatever it is. But there are a bunch of leading indicators. Doesn't mean I'm actually going to lose weight, right? They're just things that tell me, look, I think if you continue with this trend, you might change the lagging indicator, which is the total weight. And the total weight is affected by all of these different small things. Total weight can change, but at the very least, you should test it once a week or every couple of weeks, because it also goes up and down, but there's an average that comes with it. But it's very easy to measure. It's very hard to affect. So that's another difference between leading and lagging. So leading is about trying to influence future performance, but it doesn't mean that it's a goal. It is trying to achieve a goal that is not a leading indicator. And a lagging indicator tells you whether you achieved your goal. Lagging indicators a lot of times can be on our way to a goal. So if I'm measuring amount of branches or critical security issues, these are all leading indicators that are like security issues appearing in the backlog at this point. What about lagging? I can check release frequency. Right? Release frequency can be affected by many, many different types of things. I can check escape bugs, mean time to recovery. I'll talk about that in a second. And of course, eventually, it's all about the company is profitable, etc. But we have to choose where we actually stop. Okay, so a few anti-patterns. If we want to have lagging indicators and leading indicators, here are some anti-patterns that I see on a day-to-day basis. And we'll start with the two people here. So when I asked what metrics you have, one person said, oh, mean time between failures, and another person said mean time to recovery. These are two sides of the same coin. Mean time between failure basically measures, if we have a system in production, how long do we go between times when the system is down, right? So the system hasn't been down for 35 days. Or our average time is 99.999%. What's the problem with this? So who here works in ops? Just making sure. People who work in IT and deploy and help deploy, okay, a few people are kind of afraid to raise their hands. If I'm working, if I'm the IT guy or girl, and I'm trying to deploy the application, and I'm measured, if I get less money at the end of the year, right? If the mean time between failures gets smaller, then my incentive is to have as little failures as possible, which we can all agree with, right? What is the best way to avoid failures in production? Sorry? What? Don't allow change. Don't deploy, right? Hey, I can get 100% technically, just don't change anything. Now, if we go to the other side of the organization, developers. What are developers measured on? We want to do fast, agile iterations, feature flags, whatever. And they're like, we want to do multiple changes per day. And I'm the IT guy. I'm sitting there, 9 nines. And they're like, we want to do 5 deploys per day. I'm like, over my dead body, will you do that, right? Because my livelihood depends on you not doing that. So now we have two sides of the same company fighting each other because they're measured differently. So what if we switch to mean time to recovery? That's almost basically the opposite. Mean time to recovery measures how long from the moment of failure we get back to green. So instead of me being measured on the fact that I have X failures, now I'm measured on how long it takes me to get from a failure back for the system going up. So now my incentive is different. It's not about having more or less failures. It's about having short failures. So now I'm measured on maybe the resiliency of the deployment system. Maybe I'll actually have an incentive to work with the developers on feature flags or on deployment patterns. Now we have an incentive to work together. So these metrics, they actually affect our behavior because eventually those metrics are the things that managers look at. So if you get a manager looking at the wrong metric, whether they realize it or not, then technically your livelihood is depending on that metric. So part of our job is to convince our managers to use the right metrics, which gets us back to people again. Here's another one. I've seen companies measure only one of the lagging indicators. If my manager comes in and says, okay, we definitely want to increase our lead time, or we want to decrease our lead time. So we have to go fast. We want to be agile. We have to go fast. Everyone goes, okay, fast. Remove the tests. we were very fast, right? It's like hitting a brick wall at 90 miles per hour. We are fast. We got to the hospital really quickly, right? So what if we were measuring lead time, but we also measured escape bugs? We could see that we have these two opposing forces, right? We want to increase lead time, but we don't want our escape bugs to go up like crazy. So if we're doing experiments about increasing speed, what we have to do is we have to learn that these things are tied together. They're affecting each other. So we have not only, that's why people say it's sustainable or not sustainable. Yes, I can achieve faster speed, but at what cost? And the answer is maybe the cost would be escape bugs. So maybe the skill I'm missing is how do we go faster without increasing escape bugs? And companies are doing it every day, but we can measure it and see that we didn't screw up. And this is where a lot of the missing stuff happens. We're trying to change something, but we're afraid that we screwed up. Maybe our feeling as developers is, hey, this is working out great, but our managers might see a completely different picture if we're not talking about the same things. The other way around is, we cannot have escape bugs. No problem. Give me 50 people, and I'll talk to you in 6 months, right? And this is what a lot of companies do. They trade speed for what they're trying to achieve is predictability. The problem is this is not scalable because the amount of features keeps growing. The amount of variations in features keeps growing. So what happens, what we end up with, is that at the beginning this works. Slowly and slowly, it actually becomes slower and slower to develop more features. At some point, the organization, basically the development organization can collapse and say, we can't handle any more features because we have no idea. Like the comet, the tail of the comet is so long that we have no idea what we're breaking. And every time we're kind of constantly running around fixing fires. Here's another anti-pattern. Coverage, all the things. I talked about this before, right? If we have coverage, we are basically teaching people to cover. That's all we're teaching them. But if we're treating coverage and we're not using any kind of lagging indicator, we're basically treating it as a goal. And I always say coverage is a meaningless number, right? You tell me that you have 100% code coverage, I'll tell you, okay, so what does that even mean? Well, it means I have 100% code coverage, okay. But do you get more confidence? Because to me, that is a true metric. So confidence, escape bugs, and lead time. What is confidence? I want to talk about that for a second. This is something I really recommend doing at your team, something you can do at a team level. Every retrospective or the end of an iteration or a sprint or every month or every couple of weeks, you choose when, okay? It doesn't matter. But do it every once in a while. You ask 2 questions for the team. From 1 to 5, what is your confidence level that the code actually works in production, right? You've been through the code, you've seen all the ugly bits, you've seen all the nice bits, you've seen the tests, you've seen the legacy crap, right? From 1 to 5, how confident are you that that stuff actually works in production? Like between us, come on, you can tell me. So for some people might say, oh, it's like a 3.3. Some people might say, oh, it's a 4.5. Some people might say it's a 1.1. Okay. And then I'll ask, okay, what is your confidence in the test? That if there's a bug, the test will find something. Now, let's say that I have 100, like this is the red is my coverage, but the blue is my confidence. What does that tell me? It tells me that the tests are crap, right? It tells me that people are writing tests because someone told them to write tests, not because they're trying to actually prove that the system is working or not working. They're not trying to actually use the test to get confidence. The tests are there for probably a different reason. So if I ask people what is their level of confidence, that level of confidence, again, it doesn't have to be accurate. It just has to be consistent. Because for us as a team, if our average is then 2.3, whether it doesn't matter if it's low or not, what matters is that every time I run this meeting, could be weekly or bi-weekly, whatever, it goes up. That's what matters. What matters is that the confidence goes up. And that means we're actually in a better place than we were before. And confidence is a lagging indicator because it's influenced by multiple different things. It's very easy to just say, I kind of feel like it's a 3.3, and every person in the team will have a different view of the different types of code. But eventually the team will have a confidence number, and that number should be going up, or at the very least stay the same, but definitely not going down. If that confidence number goes down, you know that something in the incentive system, something is not working. And I've seen these teams where they're writing specifically tests that could be really, really crappy, right? But nobody's asking them whether the tests are crappy, it's just asking them what their coverage is. But if I go in and I ask, well, what's your confidence? You're gonna get really low confidence scores. And that is where I can make a decision, right? Not me, but the organization can make a decision. Because if the confidence is low, that leads to other types of behaviors, right? It's gonna be much scarier to change my code because I don't actually trust my tests and I don't trust my code. So I'm gonna create copies of the code because I don't wanna break it because I don't trust the tests. And now we have legacy code, duplication, and a lot of, all of these negative feelings come up again. So coverage, amount of green builds, amount of tests, all of these things, they're leading indicators, but they're not goals, they're not lagging indicators. Here's another anti-pattern, breaking the build. I used to be in the camp, I regret that, but I used to be a person that says, oh, if someone broke the build, there is a shirt that says, I broke the build, and in the daily meeting, they go and they wear the shirt because it's a fun exercise for the entire team. Such crap, because that stuff basically creates the incentive never to break the build, right? If I'm measuring you on how many times the build has been broken by the team, and I can say, well, the build has broken at least like 20 times in the past 24 hours, is that good or bad? Is that actually a bad thing? Because the builds are supposed to give us feedback. If I'm afraid to break the build, then it means I'm afraid to merge into the master branch. It means I'm afraid to create pull requests. It means that now my branches live longer and longer because I really want to make sure, because I don't want to be the one person who broke the build. So red is not supposed to be bad. Red is actually a good thing. What is bad is red that stays red. That's the behavior we want to prevent. So instead of testing amount of red builds, I want to test how long it takes a red build to become a green build. And that does that sound kind of familiar from a previous metric that I talked about? It's basically the same like mean time to recovery, but at the build level, at the development, at the branch level. If I start testing how long it takes a red build to become green, I'm influencing the behavior of the team to make sure that when a build is red, someone is actually worried about it. When a build is red, maybe the team will form like a squad that changes, and every day someone else is kind of listening to the build and makes sure that other people are involved and the build actually doesn't stay red because it means something has broken, there's actually a problem. So the team actually becomes worried about it. And to me, that is the right behavior. It's okay to break the build because that's our feedback. In fact, if I came into the team and the build hasn't been broken in like 3 days, I'm going to be like, oh, what the hell's going on here? Is there like a secret build that I don't know about? And usually there is. Okay. And that secret build is happening on a secret branch. And that secret branch has been living there for a long time. And only at the end of the iteration will it be merged. And then all the crap is going to hit the fan, right? So I know where we're going to end up if that stuff it lives forever. So I want to change it. The way I measure, the way I look at the team, the questions that I ask. So these are some examples of questions that we can ask the team. We have KPIs at the team level, specifically for continuous delivery. Feature size, if I want to teach the team about how to slice features into smaller features. If I want teams to not have long running branches, then I can test the frequency of merging into the master branch. I can measure the amount of feature flags if I want the team to start working with feature flags. But again, just measuring those things is a leading indicator. It's kind of like testing coverage. If I just measure the team on the amount of feature flags, I'm going to get a bunch of feature flags. But it should actually impact my lead time, right? Because a feature flag means that I can merge faster. It means I can deploy to various environments faster. It means I can get feedback faster. It should affect the lead time for that specific feature, which should affect eventually the lead time on the average. So I should basically couple these things with each other. So a couple of suggestions. Do not treat leading indicators as goals. Don't treat coverage as a goal. Coverage is something that you use on the way to measuring something else. You always pair leading indicators with one or more of lagging indicators. Otherwise, you're going to get exactly what you measure instead of what you're trying to achieve. Don't measure just one lagging indicator, right? Don't just measure lead time or escape bugs. Measure at least a couple of them and make sure that they're kind of related to each other. Because if you know that there is a power dynamic between those two, right? If I want to increase lead time, it's very likely to increase my escape bugs because I have, a human behavior will kind of draw me towards that. Then I will make sure that I look at both of these numbers to make sure that, yeah, we're pushing people to the right thing. We're not just pushing a number. Don't measure things without understanding why you're even measuring them. If you have metrics, understand what is the dilemma behind the metrics that you're trying to solve. If I have metrics, I know that it's about an experiment that I'm trying to do. It's about the specific transformation that we're trying to achieve. It's about a specific change that we're asking management to do. So if I'm asking for a budget for a bunch of automated test jobs and I need 50 licenses, I should be able to show what this should affect in one of the lagging indicators eventually, not just in the leading indicators. And that gives me a language to discuss with management. If you want to find out more, the blog is at pipelinedriven.org. You can ask me questions on Twitter. I recommend the Principles of Product Development Flow. That book kind of surprised me. I've been reading and working with agile development, for a long time. This book really has a bunch of really good stuff that surprised how well articulated it is. So I recommend it because it might actually surprise you. It's not a reiteration of something that you've heard a million times. It's actually a much better way to discuss it. And it gave me a new language to discuss a few different things, and of course how to measure anything. Pipeline Driven should be out in the next year or so, so wait for that. Unfortunately, that's the lead time for that book. And Elastic Leadership, ask me questions about it if you want. Don't forget to rate this session. Thank you very much, everybody.